Xi'an. This is Justin here. Please, if Justin is not here, can anyone just give us an opening prayer so that we don't spend too much time waiting?
Heavenly Father, we thank you for today. We bless your holy name. As we start, we pray that this meeting shall be successful. Let whatever we study here be used and implemented in Jesus' name. Amen.
Amen. Please, if you are not speaking, can you kindly turn off your microphone because it's causing a lot of noise. Thank you very much. So we have to acknowledge the presence of some executives in this this meeting. And to do that, we have Caleb Amamo Otu.
Please, can you hear me?
Yes, please.
Okay, thank you very much. Okay, so I would like to acknowledge the executives that we have in our midst. Now for NUGS Shanghai, we have the president in the person of Mrs. Salimatu Yakubu. We also have Kwame Ampofo, who is the vice president. We have NS Wilson, who is the secretary for NUGS Shanghai. We also have Richard Odro, who is the organizer. We have Luis Kojo Apia, who is the financial controller, and we also have Mrs. Sandra, who is the WUCOM. Okay, for NUGS Xi'an, we have Mrs. Olivia Addo, who is the president. We also have the vice president in the person of Mrs. Shelley, and we also have Mrs. Percy, who is the secretary. We have Mr. George Buedu, who is the financial secretary. We also have the organizer in the person of Samuel Ajiman, and we also have Mrs. Theodora, who is the WUCOM. So I also like to acknowledge the presence of all the other executives from the other chapters. Thank you very much for joining us. And I also salute everyone on this platform for joining us. Thank you very much. Mr. Mayor, you can take over.
Thank you very much for acknowledging the presence of our honorable executives. We are supposed to actually start the first speaker is supposed to start at 6:30, but fortunately it's 6:20. It's almost 6:20 now, so it means that we still have 10 minutes. But knowing how these kind of programs can go, I think the 10 minutes is an addition. So if he is present, we can just proceed to start so that after his presentation, maybe we might have more time, for questions and answers. So before I proceed, may I know if Dr. Yao Yevenyo Ziggy is connected? Dr. Yao. Please, is Dr. Yao connected?
Please, he will be joining you soon. I just contacted him. Yeah, he's logging in now.
Okay.
Sorry. Yeah.
And Mr. DJ Boyanyo.
This love is joke. No be joke.
They give me vibes, cause you want my body. They tell me lies, boy, not story. Not story. If you love you, want all this honey. Me, I know be Johnny. Show me the money. Money. See let's go.
Honey, honey,
What's that?
honey, honey,
Oh yeah.
honey, honey.
Somebody call the popo. Me win the lotto. Say me I don't know. Me yana, my yani don't know. Call the popo. Me win the lotto. Say me I don't know. Me yana, my yani don't know. Baby you be miracle. You give me loving way I never know. My baby you be wonderful. You give me loving way I never know. My baby you be miracle. You give me loving way I never know. Baby you be wonderful. You give me loving way I never. Oh my God, girl your love is spiritual. Oh my God, oh girl your love baby. Oh my, yeah. Girl your love is spiritual. Oh my God, oh girl your love baby. I want to shower you kisses to leave over you. And when you give me a chance to love you, I will overdo. We'll be the ex, you'll be the girlfriend. And I wanna be your boyfriend. Can we go spend this weekend? Take a choice and watch me.
Stubborn academy, 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 stubborn academy. How much be your salary? 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 Your girlfriend in my gallery, she in my gallery. Stubborn academy, stubborn academy. Small nyash they shit, small nyash they shit. Big boys they play, big boys they play. We the pop champagne, we the pop champagne. Bel Air rosé, left me make I do my thing, make I do my thing. You are not my mate, you are not my mate. MC at the craze, MC at the craze. I can't complain, I can't complain. Zatazin, tata. You dey go kitty kitty, you dey go gaga. You dey hop everywhere, you be grass cutter. See your makeup, you be karishika. I call you outside, right there. Any PK3, any PK3. Chama mesre. Chorus please. Stubborn academy, 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 stubborn academy. How much be your salary? 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 Your girlfriend in my gallery, she in my gallery. Stubborn academy, stubborn academy.
Sugar it's Mr. Drew.
The outside wants to go inside. Bounce out from
Take you for the ride.
I'm a sword 247.
I know you bad, but me I don't mind. Many girls, but me I don't like. Me too many, it's you alone. Super, although you best so me move. My baby, super, oh yeah, super. Although you best so me move. My baby, super.
Yeah, hello.
Yeah, he's in, so you can do the introduction, then he can start.
Oh, okay.
Yeah, he's
thank
in,
you,
so
Mr.
just do the
DJ.
introduction so that he can start.
Okay. And before I do that, I would like to hello. Please, if you are not talking, can you kindly turn off your microphone? Thank you. Before I proceed, I would like to acknowledge the presence of the NUGS national executives. I can see Thompson. Honorable Thompson, I see you. Yeah, we don't really have the names of those who will be present now, so pardon us, but I just want to generally acknowledge the presence of some NUGS executives before we thank you. Okay, so Dr. Yao is in now, so we can proceed. So as I said earlier, the academic research workshop is titled The Pathway to Academic Excellence. And as we all know, it's divided into 3 days. Today, we have 2 speakers. The first speaker, who I'm about to introduce, is Dr. Yao Yevenyo Ziga. I hope I mentioned your name right, Doc. If I didn't, please pardon me, okay? So he is going to treat the topic, how to identify research gaps and conducting literature review. So before I hand over to Doc, I have to give a little bit of an introduction. Dr. Yao was born in Agonaninta, Ghana in 1984. In 2008, he obtained his BSc degree in geomatic engineering from the then Western University College of Kwame Nkrumah University of Science and Technology, now University of Mines and Technology, UMAT, Takwa, Ghana. He obtained his Master of Engineering and Doctor of Philosophy degrees in Geodesy and Survey Engineering from the China University of Geosciences in Wuhan in 2013 and 2017, respectively. Since 2017, he has been a lecturer with the Geomatic Engineering Department, UMAT, Ghana. He is the author of more than 85 peer-reviewed journals and conference articles and has over 700 citations to his credit. So please, without much ado, help me welcome Dr. Yao Ziga. Doctor, the floor is yours. Doctor, your microphone is turned off. Can you kindly turn it on?
Yeah, sorry. Thank you very much for the opportunity given to me. I must say that I'm humbly honored to be here today to share my experience. I don't want us to go into too much of theoretical stuff because most of the time the research methodology that we study, in actual sense, when you go into reality, you realize that it's absolutely different. And having experience in China, because as you rightly said, I did both my master's and PhD in China from 2010 up to 20. How research should be done, as well as what is expected of you when you are given a PhD admission to come to China to come and study. So I'll go straight to my slides. So this is what I've been asked to talk about for today in terms of how to identify research gaps and conducting literature review. And as I rightly said, it's a domain that comes with a lot of differences in terms of how to go about your research work. Because I am more into the geoscience, I might be tilted so much into that direction, but I'll try as much as possible to see if I can cover many areas. But I would want this also to be more of an interactive presentation where the listeners, the audience should be able to ask questions and articulate some of the challenges they are facing. And then to the best of my knowledge and my experience, I'll be able to advise them appropriately. So my presentation is just about 8 or 9 slides. The first one will be a storyline. Then the second one will be an awareness. Then what I term as the categories of novelties that you need to understand. Then we will look at what I term as the shortcut approach, which I've used on my students here, PhD students that I've supervised and those that I'm still supervising. And then we look at one of the challenging areas, which is how to identify the research gap. So the storyline, normally when you get admission to pursue PhD, we are all happy, very, very happy that we've been given the opportunity Now, one day I will also be called a doctor. Now, I just want to share a story about a conversation I had with one of my senior colleagues. When I finished my master's and came back to Ghana in 2013, I got a call from a friend who is a lecturer at University for Development Studies. And he said, oh, I've gotten admission to China University of Geosciences, Wuhan. And actually that is where I schooled. I just want you to brief me the expectations. What are some of the things that I need to understand before I get to China? I said, well, it's a nice place. You will enjoy the place. You can have fun. But for PhD, all the conversation that you are going to hear on campus is based on SCI, SCIE, or SSCI. So that is what you need to concentrate on when you get there. Then he said, oh, as for publications, I have a lot of papers, so I don't think I'll have a problem. Then I said, yes, I know you have published papers in journals before, but the SCI, the SCIE levels are quite different from where you have already published. And he was like, oh, it's not going to be a problem. All publications are just publications. I have research experience prior to this PhD, so I'm not going to struggle. Then in 2014, I got admitted to come and do PhD. When I got to CUG, he now came to the realization that no, the journey to complete the PhD, which requires that you need to publish in the SCI journals or the Science Citation Index expanded journals, it's not that simple, and that he has written countless of papers and they are just rejecting the work. So I told him that, look, if you want things to be easier for you, whatever paper that you have written, the SCI, the SCIE, the SSCI, is not about writing, let me say, English, but there are certain indicators that they need before your paper can even go for review, because most of the time you write papers and they give you desktop rejection. The editor will just review it and say your paper does not fit to be published. And when it happens like that, you realize that all the years that you've spent, 2 years, 3 years trying to put that paper together, and someone will just take within 2 to 3 hours or within 1 week to rubbish the whole thing that you have done. And it's quite painful. So I told him that, look, finishing a PhD, and I'm talking about PhD because for the masters it's quite liberal in China, but the PhD is always a tough one. And most of the institutions have their own required journals that you need to publish. So if I speak specifically for CUG, they have categorized the journals into tier 1, tier 2, tier 3, tier 4. So you hear us talking about T1, T2, T3, and T4. On other campuses, they will do it Q1, Q2, Q3, Q4. And they will tell you that if you publish in T1, you need 1. If you publish in T2, you need 1. But if you publish in T3, you need 2. If you publish in T4, you need 3 before you graduate. Now, all these levels of categorization that have been given to you as a PhD candidate in China is not just something that is too easy, but there is a need for you to actually sit up and then consult a lot of people so that you can really, really, really break through. Now, before I start with what we have to do, like go to the next slide, my advice to all the PhD candidates is that when you write your paper, please identify someone who has published in the SCI and has experience. And you must get someone who will speak to your work and tell you that, look, this work cannot go through. You need to do A, B, C, D. Now, what are some of the indicators that are needed for you to break through the SCI? First of all, your method could be novel. I mean, it's a discovery that you have made. And on the basis of that, nobody has really applied it in your line of research. Perfect. Nobody dispute that. But if you write a bad script, the comment that will come is that just because your paper, your method is novel, does not warrant its acceptance. And these are the reasons. So the first one they will say is that one, you did not justify why there is a need for the scientific community to accept the method that you have proposed. Then secondly, you have also not justified enough contribution. We need to see your contribution to body of knowledge. Even though you are saying, oh, this is the first time this method has been used, this is the first time I have applied this technique, the technique has given me better results and so on and so forth. You must justify why the technique is giving better results. What are the advantages that the newly proposed technique is having over the old one? And then also how it can contribute to industrial applications. So these are some of the things that you have to always look at. And a paper is rejected. Most of the time, papers are rejected, not based on your discussions of results or maybe your methodology description. No, all those places could be very good. But the most important aspect of your paper is always the introduction, because it is the introduction that will give the reader or the reviewer to know the motivation behind why you are doing this particular work and why you are proposing A, B, C, D. So this is just an advice that I would want to share with my friends, brothers who are also pursuing PhD and would want to graduate one day and be called doctors. Now, the second aspect that I want to talk about is something that we usually academically concentrate on when we start the works. What is actually happening is that I will use myself as an example. And now I understand the PhD is 4 years or something, but I just want to speak to the time that I was given the admission and do the breakdown. And when we do the breakdown, you can now do the mathematics by yourself and ask questions. Now, I was admitted 9 September 2014. And in my admission letter, I am supposed to finish June 2017. Now, in my mind, I'm saying that I have 3 years. Now, let's look at the reality. Your first year starts from 9 September 2014 and will end 9 September 2015. Then on the 9 September 2015 to 9 September 2016, that ends your second year. Now your third year, which is your final year, actually starts from September, October, November 2016, which is just 3 months, and then up to March 2017, which is another 3 months. So in all, the entire PhD is just 2 years, 6 months. Now someone will say, why is it 2 years, 6 months? Now at the time, we were supposed to submit our final thesis in March so that it can go for external review in April, and then final thesis defense will happen in May and early June. Now, most of the time, the conversation that happens on campus is this. I'm doing my coursework. This is my first year. I have to do my coursework. I have to get my 18 credits. First year is gone, just doing coursework. In the second year, I'm now doing my literature review. 6 months is gone out of the second year. I'm now trying to put my research proposal together. Second year is gone. You are in third year. Then you come to the realization that, no, I've made a mistake, because in your third year, you only have 6 months. So that should tell you that when you start the PhD, and strictly with the Chinese system, if you take out the 1 year you are going to use to study the language, when you start the real PhD, you actually have 2 years, 6 months. And it is within this 2 years, 6 months that you must publish the SCI papers that are the requirement by your graduate school, your faculty, or your supervisor. There are some supervisors who are specific. even though the grad school is recommending that I should publish in T2 and T1 and graduate with 1, I need 3 papers from you. So there are different requirements based on supervisors as well as the faculties or the graduate school. Now, if you look at this calculation, and now if you are here and you are in your 2nd year of your PhD, you have to realize that you have very little time, because this SCI journals also takes a longer period even in the review. So if you are very good, then I would say that within 6 months or 7 months, your paper could be online. But if you are a starter, the number of rejections that you are going to get when the review comment comes in and they give you 2 months or 3 months to do it. So on average, you need about 1 year for the paper to come out. So if you are in your 2nd year and right from the 2nd year, you could not push the papers and you have started writing the papers in your 3rd year, then it tells you that definitely you are going to seek for an extension. And without an extension, it means that you are going to be hot. You may not even meet the graduation timelines. So this is something that I want to share, and this is reality, and it is something that everybody who is doing PhD here must take notice of, because we tend to think that in my final year, I'm going to have another 1 year. But in actual sense, the year that you are going to graduate, you only have some 3 months. Now, if you don't want to meet the June graduation, then you have to take an extension to push it to the December graduation. And even that one, you are still not safe, because the SCI papers takes a longer period for them to review. And by the time you have the back and forth, sometimes you can even go up to round 4 of review. 3 reviewers, 1 will accept it, the 2nd one will say no, the 3rd one will give comments, they gave you major revision. You do all the corrections you sent, the reviewer will still come back with some corrections. Then even sometimes, after the papers, all the reviewers have accepted it, that is the time some of the editors-in-chief will even give their comments, especially those that are really vested in the area of your research. They will also give their comments, and sometimes it's even more than what the reviewers gave you. So this back and forth is close to about 1 year. So I think that we have to take note of this, and then we can work our way around it. Now, let's look at categories of novelty. Because all this information are required for you to understand what you are getting yourself into when you say you want to do literature review. Now, this is what I have categorized the level of novelty. I say we have the localized or the national novelty, we have the continental-based novelty, and then we have what I call the global novelty. Now, when I take the local or national novelty, for example, I go into a PhD defense, and student is saying that this method that I'm using is novel, and you ask why, he says that yes, they have used it in Nigeria, they have used it in South Africa, they've used it in Kenya, but it is yet to be used in Ghana. This one, I call it the national novelty or the local novelty, because you are just restricted to Ghana. And the question is this novelty really going to be something that you can break through the SCI journals? And per my experience, little experience, I don't have much experience, but the little experience that I have is going to be really, really difficult to break through, because at this point, what you are saying that has been used in Nigeria, it means it has been done. So definitely the report or the results that were reported is going to be similar. So what have you actually done in contributing to body of knowledge in your area of research? So that is what I termed as the national novelty, or what I termed as the local novelty. Now, the continental-based novelty. The continental-based novelty is the one that you look at the African continent, you are doing a research, and you've realized that the whole of Africa has not applied these particular techniques or methodologies that people are using. Then you switch to, let's say, different continent, let's say the Western world, and you realize that consistently they've been using that concept, but it is yet to be applied within the African domain. Here is a 50-50 approach to break through the SCI, and it also boils down to how you are going to build your argument. If I want to share my experience with you, my first paper I published in Arabian Journal of Geosciences. At the time of doing the work, I was using artificial intelligence in the area of geodesy. And I noticed that there were just these few Turkish researchers that have used the AI to do what I want to do. Within the African continent, the AI has not been explored in my research area by then. So I decided to build the argument from that perspective. So I was looking at from the global level and then linking it up to the African level, where I'm trying to say that, look, this is the way to go, because now we are moving into the digital global world where AI, machine learning, augmented reality, virtual reality, IoT, that's Internet of Things, are taking over in terms of replacing or serving as alternative and automating certain systems and ways of doing things. But within the context of Ghana, I've not really, within the context of Africa, I've not really seen its application being explored. So in a way, as a contribution to knowledge, I'm trying to create awareness within Africa and the sub-Saharan West Africa where Ghana finds itself. And then also to show that, look, there is a need to be awakened into this direction. So it's a 50-50 chance, but it all boils down to how you can really put your argument in a logical manner and then defend it properly on the paper. Then we have the global novelty. The global novelty comes in different forms. Sometimes the originality they are talking about here are also in various levels. We can look at the originality from the perspective of Isaac Newton, Albert Einstein, the Nikola Tesla, and so on and so forth. But one thing that I have realized, and this is my opinion, is that most of the things that we are doing are actually based on the experiences or what these guys have proposed in literature. And we are trying to just do what I call an add-on. We are trying to add on to what they have done. If you're able to discover something from the laboratory works that you are doing, then that is fine. For laboratory works, you can discover different things based on how some chemicals react with this, maybe trying to extract some oil from some plant and trying to use it to solve some problems, some diseases. That is fine. But in geosciences, for example, it is very, very difficult to come up with an invention. So most of the research works that you see in this area are basically based on an add-on to what is in existence. So the global novelty here is that, for example, you are a petroleum engineer and you want to do, let's say, lithology classification. Perfect, there's no problem with that. Now you've seen that they are using a lot of machine learning approach to do that. So you have been doing a lot of literature review. You are seeing people using artificial neural network. You are seeing people using deep learning systems. You are seeing people using extreme learning machine techniques and so on and so forth. So you are like, oh, everything is done. No, you have to look at a different field. So you can switch from your lithology classification or in geology or whatever you want to do there. You switch to a different domain. Now, when you switch to a different domain, you can identify certain AI methods that have not been used in your area of research. And that is going to help you to bring that concept and apply within your area. And the moment you are the first to apply a certain technique, which is yet to be explored, this is what I call the global novelty, because in that field, you are the first person. So you are not even scared that in your paper title, you can even say that a novel approach to do ABCD, because you have done your search and you know that you are the first to apply this particular methodology in your line of research. So these are the 3 things that you need to consider when you are doing your literature review, as well as when you are putting your thought together in terms of the publication. Now, let's look at the shortcut approach. Now, you have finished with your coursework. You have a fair idea of the area you want to do your research, but you are kind of confused as to what to do. So, for example, if I use, let's say, petroleum. In petroleum, we have people who are into reservoir simulation and modeling. We have people who are into this production aspect, enhanced oil recovery. We have people who are into this geophysical well loss classification, and so on and so forth. So the first point is that you must identify the various specialization in your field of study. Assuming you are just blank, you don't really know what to do, but you know that reservoir simulation and modeling is there. You also know that we have those who are into lithological classification using geophysical well logs, who wants to use the well logs to predict porosity, permeability of the wells, and so on and so forth. And you know that you have people who have also gone into the enhanced oil recovery. Even some people have also gone into transportation, storage, and so on and so forth. Now you have a fair idea of all these areas that one can specialize in, but you don't really know what is happening there. So when you wake up every day, you are kind of confused as to what to do and where to go, how to start. So at this point, what you have to do is that the moment you have identified these thematic areas, at most, get about 5 published papers in these areas. So get 5 papers in reservoir simulation and modeling, get 5 papers in enhanced oil recovery works, get 5 papers in porosity prediction, permeability prediction or geophysical well loss classification, get 5 papers in transportation, storage, oil storage and gas. Now, these 5 papers that you have identified in these thematic areas or specialized areas, you need to read them. At this point, look, you don't need to understand how the method was used. No. At this point, all that you need is to get the concept to understand what is being done there. So you don't need to be reading methodology, how it was applied, result and discussion. You are wasting too much time. When you have these 5 papers, what I tell my students is that, look, at this point, you don't even know your problem statement. You don't even know how to build your argument. You don't even have any understanding of what you want to do. So your first point of call is that you have to only concentrate on the abstracts, you concentrate on the introduction, you concentrate on the conclusion. So this is what I tell my students. Go and read the abstract, go and read the introduction, go and read the conclusion. Now, someone will ask, why would I concentrate only on the abstract? But the methods too will come out that it should be novel. No, at this stage, you don't need to understand the methods that it took someone 3 years to be able to develop. And you want to take 2 weeks to understand it. It's not possible. And at this stage of your research, you have not even developed your problem. Everything in your mind is a confusion. You are in a confusion state. So you cannot really figure out how to bring your thoughts together. If the person asks you, what do you want to do? You are confused. You are all over the place. You don't even know what you want to say. So what you have to do is that since you have identified different areas of specialization in your area, what you have to do is that when you pick the 5 papers, read the abstract. The abstract is giving you the summary of the entire paper. The introduction is giving you the motive behind the work, why the person did the work, the justification for doing such work will all be provided in the introduction. Then the conclusion is telling you how the paper was concluded at the end of the day by the various authors. Now, when you do this, you can read like 15 papers a day. And by the time you finish reading the abstract, introduction, and conclusion, and jotting down certain notes, you will now understand that, oh, if I want to go into reservoir simulation, at least to the best of my knowledge, this is what they are trying to talk about. And this is the motive behind why I have to do reservoir simulation. Then, oh, if I go into the geophysical well log classification of the various lithologies of the wells, then this is what they are doing there. This is the motive behind it. Now you are trying to get the conceptual understanding. Now, those areas that you have identified, you need to rank them according to your passion and preference. We must all understand here that research is about passion. Why is it passion? It is passion because it is something you are going to do every day until you finish your PhD work. So the moment you are starting, you must have in you that you love this particular research area and it is something that you want to do. Other than that, you can start 3 months on the way, you stop, and then you are going back to search for another area. So the various areas you have identified, you need to now rank them. If you take reservoir simulation, if you take well log classification, if you take enhanced oil recovery like production, which one will you rank first? So assuming that you decided to rank the well log classification using geophysical data, you ranked it first, and then you rank the reservoir simulation second, and let's say the production and oil storage transportation third and fourth. At this point, the moment you ranked it first, that the well log classification is what you want to do, from that day, anything about reservoir simulation, anything about the oil transportation and storage, anything about the enhanced oil recovery, whatever, don't bother yourself going there again. Now, since you have said that, oh, the well log classification is what I want to do, then now, this is where you want to go. So at this point, you must now download about 10 papers in the well log classification. The reason you have to now push the papers up is that you need to now understand the various divisions, what is being done in the well log classification, because every research area has different divisions. So when you go into the well log classification, you are looking at people using the AI to do it. You are looking at people using the Petrel, the Eclipse software, and so on to do the classification. You're also looking at people using numerical techniques to do the classification. Now, because you have downloaded different papers, it gives you the room to categorize the various specializations within this well log classification. Now, even within the divisions, you have to, sometimes you need to even rank them. If it is machine learning that you are seeing is what is interesting to you, then henceforth, it is the machine learning for well log classification that you have to concentrate on. And the moment you concentrate on the machine learning well log classification, that is your PhD direction. But we must also keep in mind that identifying an area to do your research must also be in consonance with data availability. I've seen people writing very good proposals, excellent proposals, but at the end of the day, they could not execute the work. Why? Because they don't have data. So data availability is also very important before you identify your research area and even come to talk about the literature review in context. But if you think that you can get data within your area of research, and when you have ranked them and have broken it down into different divisions and you have identified the area that you want, then you can just zoom in and then start exploring further, which my professor will say you have to start digging until there is nothing to be digged there again. All these things that you are doing at this point, you have not identified the method you want to use. No. At this point, you want to understand and identify the area of your research. That is why I said you must concentrate on the abstract, introduction, and conclusion, because understanding the method at this stage has not come in at all. You need to get the concept. You need to identify why people are doing the research work. You need to identify the various areas of specializations within the research domain, and then understand how you can also put your thought together and justify why you want to do that research. Now, during that process, normally you create a table like this, and it varies. At this point, I've not added the column gap because at this point, you are still at the infantile stage where you are still trying to come to terms to the area of research that you have identified. So normally, the papers that you'll be reading, in order to get the concept and understand exactly what it means by well log classification, to understand what it means by, let's say, reservoir simulation, to understand what it means by, let's say, if we go into like renewable energy, people are doing load forecasting or energy consumption, people are doing energy optimization of buildings, and so on and so forth. In order for you to identify exactly what you want to do, this is not the time for you to be thinking about how you have to execute the method. This is the time for you to concentrate on the abstract, introduction, and conclusion to get the understanding of what has been explored there. So I create a table like this. Then the authors, let's say Ama et al. 2021. What was the paper title? Machine Learning Application for Inertial Compressive Strength Prediction. Summary of research of findings. So I'm going to get this information from the abstract, introduction, and conclusion. And I'm writing it based on how I understood it after reading the paper. Then the methods applied methodology, because in the abstract, they are going to state the methods that they've used. In the introduction, the methods that they've used and justification for using that methods will be given to you. And then when you go into your conclusion, how the methods survive in terms of accuracy of prediction or classification or whatever will also be indicated. So definitely from the abstract intro conclusion, you will know the methods that were used. So you just list those methods there. Your concern at this stage is not to understand the method. Your concern at this stage is to understand what has been done. And then when we talk about your research area, you'll be able to explain it right from the conceptual view up to the top level of knowing what in entirety involves in what you want to do. So at this stage, you still, so as I said on the slide, you still don't need to worry your head about the how the methods were executed. What you need is to understand what has been done and why it was done. And this helps you to know the motivation behind the work. And you can get all this information from the abstract, introduction, and then the conclusion. Now, having done that, so now if I ask you about the load forecasting, you understand what load forecasting is. You understand that, oh, people have used time series models. They've used ARIMA, they've used SARIMA, they've used FARIMA, they've used the gray relational models. They've even used the AI methods to execute it. And even within the AI methods, they are also using signal decomposition approaches where we are looking at, let's say, the discrete wavelet transform. We are looking at the empirical mode decomposition. We are looking at variational mode decomposition and so on and so forth to decompose data to create a time series model that can help you to do the load forecasting or energy consumption. You are looking at, okay, in a room, I want to do this energy aggregation where I fix sensors in room. It is picking data. I want to know how much energy is being consumed in a particular household. All these things, you have been able to understand what it means. So when someone asks you a question about what load forecasting is, what reservoir simulation is, what are the various categories of it, in the research domain, what are people doing, you will just be rattling. Even though you don't know how to apply the method, you will just be rattling. Now, identifying the research gap, and I always say that it's one of the toughest areas. So it's a tough call, but having understood the concept of what you want to do, and then you have been able to review papers and know exactly how the research community is going about the work in terms of the research direction, you must now move or zoom into the specifics. The specifics here is that from the table that you have created here, you will be listing some methods or questionnaire procedures they use or some laboratory experimental procedures they use. When you start listing them, when you go back to your table like this, what you will see is that you will see some particular methods or methodology or approach or a model that is repeating itself throughout. Now, what should signal you here is that it means that this method that is repeating itself in almost all, about 80% of the papers I've reviewed, is now a benchmark in what I want to do. So the moment you see that, okay, this method is a benchmark because almost everybody is using it, that tells you that whatever you have to propose, that method must be compared with what you have identified as the benchmark. Now, the question you need to ask yourself at this point is this: what is the problem with this commonly used method that researchers are comparing newly proposed method to it? And this is a very important question. Now, the moment you identify a particular technique which is commonly used in the area, what must come into your mind is that it means that there is a limitation in that method, and that is what is motivating researchers to introduce new method to improve upon what is there. So your first point of call now is that, look, I need to understand this particular method. Now, when I understand this method, before I go and read what others have proposed, and they are comparing with the method that I've identified to be the benchmark for my literature review. So when you read that method and you understand the method that has been used, you can now go to, okay, paper two. Paper two proposed this method and compared with what I have studied. And now paper two will be telling you some of the weaknesses in that particular method and how he was able to overcome such weaknesses. You go to paper three. Paper 3 too is proposing certain concepts, and that concept that he's proposing is also trying to overcome the limitations in the method that you have identified as a benchmark. So for example, because I have been doing a lot of work in the, I've been doing a lot of work in the area of the AI. And I'm sure most of you too are interested in doing research work in artificial intelligence or machine learning and so on and so forth. So for example, when we take artificial neural network, specifically like the backpropagation or the feed-forward neural network, or what some people say the multi-layer perceptron neural network, which is trained by a backpropagation algorithm. Now, one of the deficiencies that has been discovered over the years, and that has motivated researchers to be able to develop new algorithms that can improve upon the performance. Sometimes it's even from a mathematical perspective. So they are looking at the optimization methods that have been used, and they will tell you that, look, instead of attaining a global optimal solution, or what some people say the global best, the optimization algorithm that is used normally attains a local minimum. So we have a suboptimal solution. The other thing is that there are so many hyperparameters that you need to fine tune before you can get a very good result. Also, the result is dependent on the number of hidden neurons that you need to use in order to get your result. Now, when you look at such deficiencies that have been listed, you go to a stream learning machine, and you are trying to understand that Juan et al. And co. proposed the ELM, the stream learning machine, to overcome the limitations of the backpropagation algorithm. So you go into the the area of optimization of the AI, the hybrid AI methods. And you tend to realize that instead of using the numerical optimization methods, such as the Levenberg-Margot, the Bayesian regularization, the resilient momentum, and so on and so forth, the scale conjugate gradient optimization, they are trying to use what they call the bio-inspired optimization, or like the meta-heuristic methods based on nature inspiration, to be able to optimize the same backpropagation to improve the result. So when you identify a weakness and you start reading the papers, that is when you'll be able to identify what other people have done in order to overcome such limitation and improve the performance of what the result in terms of prediction or in terms of enhancing the convergence of the method. Sometimes the result could be the same, but when you look at the convergence rate, you will see that one converges faster than the other. So in terms of the runtime, you are looking at the method that produces the least runtime to be able to do that. So let's say you are doing a research in fault diagnostics. In fault diagnostics, assuming you have read a lot of work and you've seen that you are not getting a headway, you want to use the machine learning, you must first of all understand that in the area of machine learning, what are we looking at? We are looking at prediction, we are looking at classification, we are looking at pattern recognition, we are looking at clustering, and then we are looking at what? Time series prediction, and then also feature selection. So when you are able to understand these categories that constitute the entire machine learning works, and this one I'm speaking strictly with respect to we in the geosciences, because the electrical engineers who are into robotics and so on, their concept and how they are using the AI is quite different from how we write the script to execute our tasks. But even that one, you still notice that, look, in the robotics, some people are looking at bringing emotional aspect in robot because they think that the robot should be able to have emotions and so on and so forth. And it's something that people are exploring. So maybe you can decide, okay, then why don't I go into the emotional artificial intelligence, maybe brain inspired emotional neural network and so on and so forth. So identifying the research gap is a tough call, honestly speaking. It is not something that is quite easy. And for practicality's sake, I will say that you start from identifying the commonly used methodology in your area. Then you now look at the papers that have brought new ideas. So from the new perspective or from the new ideas that have been presented, you will be able to understand why they are leaving the old one and bringing the new one. And with much reading, you'll be able to look at, okay, this particular person brought this idea. This particular person also introduced this concept. How can I bridge the two together? Is it possible to hybrid them? Is it possible to consider these two methods? And most of the time it is possible. So the moment you bring these two concepts together into your domain, then it becomes a novelty. So that is what I can say. Then, in addition to what you have started, the following are very important. So what I mean is that if we go back, what you have started, okay, this method is widely used. I'm seeing that a lot of people are bringing different concepts. Now, someone is saying, let me optimize the AI using bio-inspired algorithm. Okay, now let me identify the newly determined optimizers. So you go in online and you are seeing, let's say, the reptile search algorithm. You are seeing, let's say, the anti-coronavirus optimization. You are seeing coronavirus optimization. You are seeing Ebola optimization. You are seeing child drawing optimization, and so on and so forth. These are newly determined or developed optimizers. So it means that if I use search optimization method to optimize my ANN technique, it's going to be a novelty. And the novelty is coming from the fact that, look, these newly developed optimizers are more powerful than the widely used particle swarm optimization, the genetic algorithm, artificial bee colony, and so on and so forth. So you'll be able to identify your novelty right from the word go. The other aspect is that, look, I want to develop a controller. I'm doing process control. And I've realized that, look, all the research work, they are doing fuzzy PID controller, they are doing PID controller, they are trying to say that the linear controller and then the nonlinear one is not, you need to get a system that can handle both linear and nonlinear. I've looked at it, everybody has done all this work. I don't even know where I have to go. But you must also know that maybe very few people have tried to apply a hybrid of the optimization to the controllers that they want to develop. So all that you are seeing in literature is that someone has used PSO to optimize a fuzzy whatever controller. But has somebody used, let's say, anti-coronavirus and African vulture, these two optimizers combined together as one to optimize the fuzzy PID controller? So this is how sometimes you come up with some novelties, but most of the time you need to digress and move into a different domain to see what they are doing there and adopt their concept and bring it to your area. So having said that, identifying a research gaps also involves what? Broader consultations with your supervisor or your advisor, your colleagues from different disciplines. It's very, very important. You cannot do PhD and you'll be like an island. You don't consult. You are just doing everything in your room. No, you need to discuss. For example, you are a mechanical engineer and you are doing your PhD. You want to develop a crusher, and that particular crusher, its performance level should be better than what is in existence or what have been proposed in literature. Maybe at some point you are getting confused. If you have a mathematician who is into optimization, go and ask him, oh, this is what I want to do. How can I optimize my design so that at the end of the day, the output will be better than what is in existence? So sometimes interdisciplinary conversation or collaboration in terms of discussing your problem also helps a lot for you to identify the research gap. Because at this time, you have read all the literature, you have identified all the methods, but you have in mind that you want to optimize something. You have in mind that you want to improve the performance of something, but you are getting confused. And normally in engineering, everything is about mathematics. So you need to consult maybe a colleague in hydrogeology, a colleague in geology is also doing mathematical modeling. You talk to him, he's telling you that this is what I'm trying to do. You look at your problem, and then you further explore on how best you can apply his concept to your concept. And that helps you to move fast. But if you want to remain an island, then you are going to struggle, because everybody, one way or the other, at the beginning of PhD, required consultations. And it is very, very important. Now, if your work is a mathematical modeling approach, it is always good to see the extent at which it has been implemented in different research areas, and it helps a lot. Then most at times, the discovery of novelty comes from what? Interrelated disciplines. And as I said, if I use myself as an example, when I started the PhD, the AI has not been used in the coordinate transformation works that much because there were some few people. So I have to dig deep and identify some of the methods that are yet to be applied there. But I was reading papers from petroleum, geology, environment, and so on and so forth. For example, you want to understand trend of, let's say, particulate matter distribution within an area. You are doing environmental science, and you want to create a model that can predict the particulate matter. Now, most of the time when we are doing our trend analysis, we just plot the graph, we look at the graph, and then we say, oh, in January, there was a high peak here, in February, it goes down, and so on and so forth. But mathematically, you want to use a mathematical technique to do that. So sometimes from consultations, someone will say, oh, I saw a method, a paper somewhere, they use a technique called fractals. So can you explore that and see how best you can also use it in your area? Fractal work is purely abstract mathematics, but you see that someone has applied it in environmental engineering in some area. Now you are bringing it into your PM 2.5 and PM 10 area, and that helps you to move faster. So the interrelated disciplines is very important. You can just digress more to understand what is being done in different areas. We must also know that multidisciplinary research is the way to go. Because, for example, if I take an area like deformation studies, those of you who are doing geotechnical engineering, or for myself, an engineering geodesist, deformation is something that the civil engineer studies. They normally will say structural health monitoring. The civil engineer is doing it. So let's say the geotech engineer. Now, me as a geodesist, I'm also studying the deformation of structures, the health status of structures. Now, if I go into the geotechnical engineer, and the reason why I'm saying that consultations and multidisciplinary consultations are important is this. The geotechnical engineer is looking at bearing capacity, point load or point index, the bulk density, is looking at pressure, is looking at the rock properties and soil properties, these elastic modulus and so on and so forth. And it's even looking at, if it is in the mining area, is you looking at all these things to even determine the factor of safety for a particular slope, because it's looking at how the wall is stable and so on and so forth. Now, when you come to engineering geodesy, we are looking at what? The coordinates, the X, Y, Z. We are looking at how we can use the coordinates, eastings, northings, the location, to be able to calculate for displacement. And on the basis of displacement, we'll be able to know whether the structure is shifting or not. We are all doing deformation studies, but our concepts are different. So the question is that you, as a geotechnical engineer, you can come out with an idea that, look, I need to create a unified approach. And why do I need to create a unified approach? I need to create a unified approach because at the end of the day, we are all aiming at one particular thing, which is safety. And the safety we are talking about here is about deformation, the health status of structures. So why can't I merge the data that is being used by the geodesists, add it to my input parameters, and then create a model? Or, okay, if I look at what I determine as deformation from a geotechnical perspective, and what a geodesist is determining as deformation from an engineering geodesist or surveying perspective, what is the relationship between these two? This is something that you can explore. So that is why I'm saying that multidisciplinary research is important. At this point, I think I want to thank you so much for giving me the opportunity to share my experience. I didn't want it to be so much of theoretical, because the theories most of the time in the research doesn't really hold, but it must be as practicable as possible. So thank you for the opportunity given to me. Questions, comments, suggestions, we are all here to learn and improve upon our knowledge. I wouldn't say I know everything, but this is the little that I know and I want to share. Thank you very much.
Thank you very much, Doctor. That was a very insightful presentation. Thank you very much. We have learned a lot. I personally have learned a lot, and I hope my colleagues too have learned a lot. Now we have just about, we have about 15 minutes to ask questions. So please, if you have a question, you can raise up your hand or you can type it in the comments section so that I will read it out. Amo Mensa, your hand is up, right?
Yeah, yes, please.
Okay, go ahead.
Okay, thank you very much for the wonderful presentation. So my question is, you made mention of taking some ideas, as in, let's say, from other colleagues. So if they use a particular method, right, and you also put it in your design, meaning that this thing will be very new. So in such cases, how do you do the comparison? Because it's new and you have to also compare. So how do you do the comparison based on other literatures that has been done already? And also, is it advisable? Okay.
Yeah, go ahead. Go ahead.
This is a follow-up question. Is it advisable? Let's say I've designed, right? Then I used a method, but I did not compare it with other literatures, but I compared it with my own proposed two methods, right? So let's say I developed two methods and I compared both without comparing it with other literatures. Is it advisable to also do that? So that's my question. Thank you.
Okay, thank you very much. I'll try my best and answer you. The first one, you said taking ideas from different colleagues and then implementing it in your design. Now, if I understand the second, even the two questions, what I'm seeing is that you are doing something that is yet to be used in the area. So it's like you are the first person to pioneer that idea. Is that right, Amu?
Yes, yes, please, exactly.
Very
yes.
good. So normally, this is what you have to do. In the write-up, for example, in the introduction, you have to tell us what has been done in other disciplines. It's very important. Then, because that is what is giving you the justification to propose what you are proposing. So at the end of the day, whatever you are presenting there, you are going to state clearly that this study proposes or propose a novel something, something, something. And then you are going to list whatever you have done. But in your introduction, because other disciplines have applied them, you need to specify. So I had similar problem. I published in Mathematical Geosciences, and I was trying to test the capability of ANN to as a forward convention method. At the time, nobody has explored even the AI to do that forward convention. So in the introduction, I think one of the reviewers said, look, there is a need for us to see the ANN that has been applied in your geodesy field. So now I have to go and look at how review and give examples of papers that have been used for orbit determination, for gravity anomaly prediction, for deformation studies, and so on. So I presented all these. Then I made the argument that although these methods have been explored in the above or in the aforementioned areas, the study, the technique or the methodology is yet to be explored to ascertain its capability in this area. So at the end of the day, it's more or less like you are assessing the capability of that particular work that you have done in the designing of something. So you can build your argument from that perspective. And the comparative study will be based on what you have done, because there's nothing for you to compare. You cannot go and compare with what somebody has used in a different discipline. No, but what the person has used in that discipline is actually helping you to build your argument that, look, when it was used in this discipline, it is helping me to get, it is now motivating me to apply the method here, because the result that is being reported shows that it's a quality work, it's a quality method which can really give very good accuracies. On the basis of that, I want to do A, B, C, D, and you build your argument. So when it comes to the comparison, it is what you have done that you are going to compare with. You cannot go beyond that. But if maybe one or two methods have been used in your area, which is purely classical approach, then you are entreated to pick one of them to compare with what you have done. But if there is nothing there, like the way I had that experience, all that I did was to develop my models, compare and choose the best out of it. But at the end of the day, the presentation was clear that these methods are yet to be explored in my area. I don't know if I have answered your question, Amu.
Yes, yes, you've answered it. One more thing. So let's say like you've proposed an algorithm which has already been used, right? And let's say you design a system, like a different design, and you put this algorithm inside the design, but a work has been done already, and the design you did is different from what that person also did. but the
Yes.
algorithm it's same. Let's say you've also improved the algorithm. So in this case, it's okay to compare both, right?
Now, since you said the design
is not the same.
I'm sorry. Can please, doctor, can you make the answers a little bit concise so that more of the guys, because I see some questions coming in.
Oh, okay. If the designs are not the same and the output of whatever you have designed is not the same as what you have, then it means you cannot compare. But if the output of the existing design and what you have done are the same target, then it means that you need to now show us what you did to improve what you have done.
Okay, thank you very much. Thank you, it's answered.
Okay, Osai Tutu, you can ask your question now. And please, just one question so that others can get a chance. And please make it concise.
All right. Thank you very much, Doc, for a wonderful presentation. Indeed, you have said it all. Please, what I actually did was I found out about several review papers, and I read them, and I discovered some, weaknesses and the strengths. So I used some of the weaknesses in a research about those weaknesses, and I found out that has not been done. And I try to use those weaknesses as a novelty in my field of study. I would like to ask, is it also appropriate, or is there a nice way, as I did, or the approach I use? Is it good using the review papers, discovering the weaknesses, and to use them as a novelty in my field of study? Thank you.
Thank you, Osetutu. It's very good. It's very good. Because at the end of the day, if you listen to the presentation, I made mention of you identify like a technique, you look at the weaknesses and how it is being improved. So it's a good strategy. There's no problem. It's really good.
Okay.
Yeah.
Thank you very much.
Okay, before I call the next person, I think there's a question in the comment section. The person says, can you elaborate more about writing a paper that many have researched on, but you as a researcher, you know that there are gaps in? I don't know if you get the question.
Yes, I've seen it. I should elaborate more about writing a paper that many, for example, there are some research areas that you see a lot has been done. For example, for diagnostics, a lot of work has been done there. Now, before you can identify the gap, you have to really have an in-depth knowledge and understanding of what has been done. And on the basis of that, you can now say that, okay, this is what I want to do, because every research has a limitation, irrespective of whether a novelty is proposed or not. There are limitations in every research work. Fortunately, sometimes people will put future research direction as part of their conclusions, and that helps you. But other than that, you must first of all know what has been done, the weaknesses in what has been done, and that now helps you to push ahead to identify what you want to bring on board.
Okay, thank you very much. The next person is Adolfo Snako.
Hello.
Hi.
Yeah.
Thank you very much for the opportunity, and thank you for this discussion. I've learned a lot. I have just one question about discussing your ideas or discussing what you want to do with colleagues and with maybe people from other disciplines. Because I've heard stories, I'm yet to do my PhD, but I've heard stories about maybe you do all that research, you identify gaps, you start having ideas as to what you want to do, and then you want to discuss it with a colleague, sometimes in your professor's group or in a different group, just to, help you out with coming up with some solutions to certain problems you found. For example, how to go about what you want to do to achieve the results that you have in mind. But then you find out that that person ends up taking your idea and making it theirs. And then they present it, especially if they're ahead of you, they present it as their, thesis presentation and their idea for a paper or whatever. And then in the end, your professor just tells you to just let it go and then just do something else. How do you deal with this kind of environment? And sometimes it happens to foreigners who discuss their ideas with their Chinese colleagues, and then the Chinese colleagues pick it up and then present it as theirs, and then the student is told to just let it go and then do something else. How do you deal with such an environment or such a situation in terms of discussing your ideas with colleagues?
Yeah, thank you. I have a friend who faced the same problem. As you said, he was from Pakistan. And as you said, you know, one thing I have realized is that it is difficult to come up with new ideas or discoveries. So when it happens to the Pakistani, as you rightly said, the professor said he should just forget about it. And that was what happened. But this is what I did. I wanted to use AI to do my work. But the discussion I was having was actually with a guy who was doing AI in geophysics, who is not even part of my professor's student. Because he was then from, he's from this place, Guinea. So Konate was using AI to do these geophysics works. So I was having a lot of discussions with him just to understand what he's doing and how I can apply it in my domain. Now, in the case of having discussed it at the supervisory level, when I was asked to present what I want to do, I was always presenting what is in existence and then trying to hide the main concept and methods I want to use. So I will always present that I want to use artificial neural network. This is what I want to do. But the method within the artificial neural network, I'm still ready to explore. And that ends it. Because most of the time, we, the engineering students and geosciences, geology and so on, apart from maybe you are doing petrographic or these petrogenesis things, strictly from mathematical modeling, we always try to use the methodology to help us to bring our novelty and graduate. So the method that you want to use actually for your work, and then the idea behind it, no. But on a broader perspective, you can say that this is what I want to do. But what you really want to do, you don't have to discuss it within the panel, your supervisory team. You have to discuss with colleagues who are using similar techniques to do their works outside your supervisory team. And that is the only way out. Other than that, you struggle, get the ideas you present, and by the time you realize it has been published, and you have to start all over again. Thank you.
Thank you very much. For our time is almost up, but we'll take one last question from Alima to Sadia.
Okay.
Hello.
Hi.
Please, my question is like with regards to using data from World Bank.
Sorry, please, do you have two things connected? I mean, two devices connected.
Yeah, is it okay now?
Yeah.
Okay. So my question is, yeah, you can hear me now, right?
Yeah, we can hear you.
Yeah, my question is like with regards to using data from World Bank. So like assuming like you are taking data from World Bank with regards to like countries, and sometimes you find out that maybe you need up to certain year, like maybe you need data from 2015 to 2018. But in other countries, like you can find data up to that year, but certain countries maybe you will have up to maybe 2017. But you need maybe some of these countries, maybe you need data from them. How do you handle such problem?
Thank you. Sometimes, like the World Bank data, especially within the African system, is very difficult to get all the information that you need. So you might have to contact the various ministries in charge of that particular area that you have identified that you want to use from the World Bank. Because the World Bank will always give you a summary of the data. maybe yearly data or quarterly data. But if you want an extra information about the data set, sometimes you may have to contact the ministries, because the ministries are the people who will gather the data. They are the people who will do the World Bank project. And then they are even the people who write the report for the World Bank expert to also review. So most of the time, the ministries will also help you to get the required number of years data that you want. However, it depends on what you want to do. If, for example, you are doing a work in poverty, it means that if you don't get current data, it's going to be difficult. But if, for example, you are looking at population, and then you can get up to certain year, you can even do a projection into the future. So it all comes down to what you want to use the data for, and the purpose is going to serve you. But at the end of the day, if you want an elaborate data set to understand the meta information about the data, then the ministries involved should be contacted. Thank you.
Okay, thank you very much.
How do you get access to the ministry?
Come again.
Like, how do we like get access to the ministries you say like that are
Yeah.
getting data from African countries with regards to e-commerce?
Okay, so normally, what I did was that I submit my proposal, maybe through an email. You submit the proposal to the agency. If you have the HR manager or maybe the head of the agency, you send your proposal. Then in the email, you stipulate what you want and what you intend doing with the data, so that if there is any confidentiality forms that you need to sign, you sign. So normally they have to see your research proposal, and then also you need to indicate in the mail what you intend doing. At least when you send about 5 or 6, you may get 2 or 3 that will respond to your needs.
Okay. Thank you very much. Sorry guys, for the want of time, we cannot take any more questions. Thank you very much, Doctor. It was a very insightful presentation, and the answers are really, someone said he missed the presentation, but your responses are top notch, and we really enjoyed the presentation, and it's been very helpful. Thank you very much.
Thank you to NUGS, and I wish all the Ghanaians the best of luck and success in their studies. Thank you very much.
Thank you. All right, so I guess now we will have a short break, just about 5 minutes, and then we come back to have the second presentation. So, Mr. DJ Boyano.
Although you best so me boo, my baby shuberu, shuberu, beru. Oh yeah, shuberu. Although you best so me boo, my baby shuberu, shuberu, beru. I don't wanna know if you got a boyfriend. I just wanna know, baby, if you feeling me. Are you feeling the boy? Cause I go fit give you better. I go fit treat you better. Make I love you better. Yeah. Beautiful, beautiful, oh my tomato. Baby, beautiful, beautiful, oh my darling. Semen shower, come on, tete. What do you come me? What do you shock him? What do you kick me? I made a hand. Peru, 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 Peru. Shoo, Peru, 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 Peru. Samete wonyana miti Miami do.